These are the solutions for Algebra Study Guide Quiz 6. So let's take a look at our first problem here. Here it asks us to solve the inequality and write the answer in set builder notation. So I'm going to use the distributive property first. I'm going to take this -1 right here. So if anytime I see a minus sign in a parenthesis, it just means the opposite of what's inside the parentheses. So I could always put a -1, or at least a 1 between the minus sign and the parenthesis, and distribute that. That would leave me with 5 minus n plus 4. Make sure you have a plus 4 there when you're going about doing your distributive property. That will be a common mistake most people will make. On this side, I end up with a 3n plus 6. So I go ahead and work a little further. I'm going to go ahead and collect some like terms. Don't look at the sign behind. Look at the signs in front. Positive 5, positive 4 makes a 9. And then I'll go ahead and bring down the inequality sign and the 3n and the 6. So I go ahead and start moving some terms around. I'll subtract that 3n from both sides. And I'll also go ahead and subtract the 9 from both sides as well. So I end up with a -4n is greater than or equal to -3. Same sign, I add, opposite sign, subtract. So from this point, I'll divide by the -4, and that'll do a couple things. First of all, it'll switch the inequality sign around, so I got now n is less than or equal to 3/4. So the set builder notation looks like this. We've got our brace signifying a solution set, and all values of n such that n is less than or equal to 3/4 is what I'm looking for, and then close the brace. So let's take a look at the next one. It says matter is in liquid state when its temperature is between its melting point and boiling point. Melting point of mercury is -39 degrees Celsius, and its boiling point is 357 degrees Celsius. Find the range of temperatures in Fahrenheit for which mercury is not in a liquid state. So first thing I'm going to do is take this formula right here, and I'm going to convert it to Fahrenheit. So I've got to go ahead and multiply this equation by 9/5 on both sides. So multiply this side by 9/5 as well. And what that'll do for me is it'll leave me at 9/5 C is equal to F minus 32. So then I could just add that 32 to both sides, and I've got F by itself. So Fahrenheit equals 9/5 times by C plus 32. So now what I can do is I can take those values that I have here, -39, and plug it in for the C value. So let me go ahead and do that. I have Fahrenheit equals 9/5 times by -39 plus 32. So when I go ahead and do all this work, I end up with multiplying 9 times -39, divide by 5, plus 32, ends up equaling -38 2/10. I do the same thing on the other side. So I've got substitute in for C, substitute the 357, and then I go ahead and add the 32 once I multiply by 9/5. So 9 times 357, divide by 5, plus 32, I end up getting a value of 674.6. So they said, well, what is the range of values? Well, it says that the mercury melting point for mercury is -39, and its boiling point is 357 degrees. And so I see that the values of M would be between these two numbers if it were in liquid state. But we've got to read carefully here. It says when it's not a liquid state. So that means it's not between. So not between means that the mercury temperature is going to end up being below this temperature. So below -38.2 and below or above 674.6 degrees Fahrenheit. So we first had to figure out what those two values were, those two endpoints, and then go ahead and write in our inequalities. So because it's not equal, not in liquid state, it's going to be below the -38.2. So M is less than that, or M is greater than the 647 or 674.6. So let's take a look at the next one. It's solving in or a absolute value equation. So I'm going to subtract 6 from all sides. And when I do that, I have the absolute value of 3h minus 2 equals, I should be subtracting 6 from both sides here, I get equals negative 4. And there's our problem. See, I've already got the absolute value by itself, but it equals a negative. So I can't have the absolute value cannot equal a negative. And so since that's the case, since I have it equal to a negative, that means we will have no solution in this case here. So that's what we get for number 3. So I'll box the different answers that we should be seeing here. And those are the first 3. Let's take a look at the next set of 3 problems. And it says we're supposed to solve this equation, and we'll just go ahead and do some opposite operations. So I'll add 1 to all sides. Notice I still have this 4 in front of the absolute value bars. And so that means that it's being multiplied, so I'm going to do an opposite operation to undo that. I'm going to divide. So now I have 2y minus 3 inside some absolute value bars equals 3. So now I'm ready to set up my 2 equations. So the values that I could have that would make a 3 when I take the absolute value would either be a negative 3, like I set 2y minus 3 equal to, or positive 3. So then I go ahead and solve for those values of y that make that the case. So I'll add 3 to all sides. I'm getting 0 equals 2y, which also equals 6. So when I divide by 2, I get my 2 endpoints. So 0 is one of them, and the other value is 3. So when I go ahead and set that up, I get 0 and 3 as those 2 solutions. Let's take a look at the next problem. It's an absolute value inequality. So we solve these the same way, but making sure before I write down that 3, whenever I look at an inequality, that's absolute value, and I see a greater than symbol, I think of greater. And so I know it's going to be an OR statement. So 3d minus 7 is greater than or equal to 28, but it's going to be less than or equal to negative 28 because it's an OR statement. So I go ahead and solve this by doing opposite operations. I'll add 7 to all sides. Over here I'm getting negative 21 is greater than or equal to 3d, which is greater than or equal to, and this makes 35. So when I go ahead and divide by the 3, I'll get negative 7 as one of the values of d, and the other value is a decimal. So 3 goes into 3 one time, goes into 5 one time, and with 2 left over, so 11 2/3. So the values of d are either going to be less than or equal to negative 7, or d is going to be greater than or equal to 11 23. So I go ahead and solve or write the number line, draw the number line there, and I'll put negative 7 greater than or equal to, so close circle, and the values of d are less than that value, and the values of d are greater than 11 2/3. Let's take a look at our next one here. We have a different inequality sign. We've got a less than, and so when I think of less than, I think of less than, and so if we think of that, if we remember that little phrase there, it'll remind us that whenever we have less than, as long as the inequality is isolated, and when we have less than, that means that it's going to be an and statement. So let's set it up. 3c minus 4 is less than 12, but greater than negative 12. So when you go ahead and add the 4 to all sides, we end up getting a negative 8 is less than 3c, which is less than 16. So 3 is not going to go into either of these two numbers evenly, so I'll just write them as mixed numbers. Negative 2 2/3. C is greater than that value, so greater than negative 2 2/3, but less than 5 1/3. And so when I go ahead and graph that, I'll put negative 2 2/3 in the center, and I'll put 5, or at least off to the left, and then off to the right 5 1/3, and the values of C are in between. C is greater than the negative one, the smaller one, but less than the positive, larger one. So that's what we'll end up seeing. So let's take a look at our next set of 3 problems, and the first one says a company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. So more than 5 grams. So when we go ahead and set this one up, we want to write and solve a absolute value inequality for the allowable weights. So x equals a weight of box, and so let's go ahead and set it up. X minus 213, because 213 is what it should weigh. And so if we subtract 213 from the different amounts and take its absolute value, we'll find out if that value is surely less than 5 or not. So I go ahead and set this up as x minus 213 is less than 5, but greater than positive 5. And the reason why I didn't set it equal to, because it said it can vary from the weight by more than 5 grams. And so anything that varies more than that is going to end up being sent back. So if it's more than, it would end up being sent back, but if it equals, we would not send it back. So I'm actually going to change that to a less than or equal to symbol, so it'll equal 5 grams. That would be okay, because it's not more than 5 grams. So we'll go ahead and use that, and I'll add the 213 to both sides. And that should be a 213. And I'll go ahead and add 213 to this other side. And so when I do that, and this is negative 5 on this side, so when I go ahead and do that, I end up with 208 is going to end up being less than or equal to x, and x is going to be less than or equal to 218 grams. So this is the range of weights that we could end up having. See, if x was 218, that's 5 grams more, 5 grams more than the original, but not more than 5 grams more. So 5 grams is okay, but anything more than 5 grams, like 5.1, would be unacceptable. So we had to do 2 things there, write the inequality, which we have right here, and write the solution for that. On these we have to name some properties. So what I do first is check to see if order changes. 59E, 59E. Order did not change, but parentheses did. So that's called the associative property. Associative property of multiplication. Here we are adding 0 to a number. That's called the additive identity. And over here we are changing order, J and G, G and J. So that's called the commutative property of addition. So looking at the next or last problem, says write and solve an equation for the situation. 2 friends rent an apartment. They have to pay the landlord 2 months rent and a $500 deposit. And so when they sign the lease, the total amount they pay the landlord is $2,800. And so here's some information that's important to us. We want to find what is rent for 1 month. Let's call R equals rent per month. So let's go ahead and find out what we've got. So we've got 2 months rent, so 2M, or 2R, plus the $500 that we paid, and this should equal $2,800 because that's what we paid that month. So let's find out what the rent is. Well, for 1 month, so let's subtract that $500 from both sides, gives us $2,300, and then this equals 2R. Well, when I divide by 2, I find out that the rent for 1 month is equal to $1,150. So there it is. So those are the problems that you'll see on this week's test. Good luck.